Okay, so today we're looking at geometric sequences. Our goal is to sort of look at the formula for finding the nth term in a geometric sequence. We'll start with an investigation. If you'd like, pause the video and have a go at the investigation for yourself. Okay, welcome back. So hopefully you had a look at this. Let's see what we need to do here. So with the investigation, we need to find the next terms in the sequence. So this sequence, if we look here, we're going up by multiplying by 2 every time. So to find the terms in the sequence on our calculator, we can type in 2, which is our first term, and then each term is made by multiplying by 2. So we get 2, 4, up to 16. So the next one is going to be 32, 64, 128, 256. Let's have a look at B. So in B now, if we look at our terms, we are multiplying by 3, but the sign is changing. So we're multiplying by -3 each time. So if we start with the first term in the sequence, we need -1. And then we're going to multiply by -3. We get 3 minus 9, 27, minus 81, 243, minus 729, 2187. So here we got a bit of the middle term in the sequence. If we look here from 6 to -3, then we're dividing by 2. We can see that as multiplying by 1/2. So let's try that one now. So we're at 6. We're going to multiply by control divide 1/2 gives us 3. 3/2, 3/4. The next terms are going to be 3/8, 3/16. So if multiplying by 1/2 moves us forward in the sequence, dividing by 1/2 or multiplying by 2 will move us backwards in the sequence. Let's try that. We try from here. So if I multiply by 2, I can move backwards through the sequence till I get to 6. Ooh, sorry, this should all be negative. So let me kick. Oh, my screen sharing stopped. Okay, so we're at -3. -3. Multiply by 2, -6, -12, -24. Have a look at D. So if we see here, we're multiplying by 5. So to move backwards in the sequence, we can either divide by 5 or multiply by 1/5. So 125, our term at the end, divide that by 5. It's going to give us 1/5, 1/25, 1/125, 1/625. Okay, so the important part about this is how to find the different terms in the sequence. So if you take the second term and divide it by the first term, for the first sequence we get 2, third by the second we get 2, the fourth by the third we get 2. I'll do this just for term B. So for B, the second term in the sequence is 3, divide by -1, we get -3. The third term in the sequence is -9, divide by 3, get -3. The fourth term is 27, divide by the third term, -9, we get -3. So what we notice here about what we call the common ratio. So in arithmetic sequences, each term is connected by the common difference. In geometric sequences, each term is connected by the common ratio. And we can see that the common ratio R is going to be given by when we divide consecutive terms. So if we divide the nth term in a sequence by the one before it, we will get the common ratio. This formula is not in the formula booklet, and it's important for this topic. It's the central formula for the topic. So we see that any term divided by the previous term is going to give us the next term in the sequence. So un divided by un minus 1 will give us the previous term. So looking now then here, how are the terms connected? So you move from one term to the next by multiplying by the common ratio. We can see this here. We multiply one term by multiplying by the common ratio. So to get to the third term, we start at the second term, multiply that with the common ratio, it brings us to the third term. But if we start at the first term, we multiply the common ratio, gives us the second term, multiplying again gives us the third. So we sum this up and we get this sort of R squared. So to get to the fifth term, we're going to need to multiply the fourth term by R, or in other words, the fourth term can be made by multiplying the first term by R cubed, which means to get to the fifth term, we can take the first term and multiply by R4. So the nth term formula then, which is the important one, is you can get to the nth term in a geometric sequence directly by taking the first term, multiplying by the common ratio, minus 1. We don't have to multiply the first term by R to get to it, because you're already at the first term. You have to multiply every term by one lot of R to get to the next term. So if you're going all the way to the nth term, you need R minus 1 lots of the common ratio. This is our formula for this. So for a geometric sequence, we have the formula for the nth term in the sequence. We can see that here. So to get to the nth term, you need the first term multiplied by R to the n minus 1. It's easy to see if a sequence is geometric because there's a common ratio between the terms. So these are geometric sequences. We need to find, so let me do the first one. We need to find what is the first term in the sequence, the common ratio, and the 10th term. So let's do A. So the first term in the sequence, U1, equals 2. The common ratio, R, is going to be U2 divided by U1. 6 divided by 2 gives us 3. Set up the formula for the nth term. That's going to be U1 times R to the n minus 1. That's going to be 2 times 3 to the n minus 1. This is our formula for UN. So now we want to find the 10th term in the sequence. We want U10. We take 2 times 3 to the 9. Try that on our calculators. 2 times 3 to the power of 9. The 10th term in the sequence is going to be 39,366. Pause the video now and have a go at finding the same process for the next two terms. Okay, welcome back. All right, let me do B for you, see whether you were successful. So the first term in the sequence is going to be minus 3. We need to find the common ratio. We take the second term in the sequence, divide it by the first term in the sequence. We get 6 divided by minus 3. That's going to give us minus 2. So our formula for un is going to be minus 3 times, put a bracket around this if it's negative, and we need this to the n minus 1. This is our formula. So we need to find the 10th term in the sequence. We need minus 3 times minus 2 to the n minus 1. 10 minus 1 is 9. Let's try that on our calculators. We need minus 3 times bracket minus 2, close bracket, to the power of 9. Let me put it here. That's going to give us 1,536. Let's have a go at C. U1 is 16. R, U2 divided by U1. 8 divided by 16. Try that on my calculator. Looks like a half. 8 divided by 16. Half. So our formula, un is equal to 16 times half to the n minus 1. This is our formula. So U10 is 16 times a half to the n minus 1. That would be 9. Tap this into my calculator. 16 times a half to the power of 9. Over 32. Okay. Let's try a couple of problem questions. So Caroline is starting a new job. She earns 48,000 in her first year. So for question 2, that means U1 is going to be 48,000. Her salary increases by 5% each year. So for percentage increase, we take R, the common ratio, to be 1 plus the percentage increase. If it's decrease, we would take R1 minus the percentage decrease. So this one is for increase, this one is for decrease. So we've got R equal to 1.05, 5% increase. Show that the annual salary follows a geometric sequence and state the common ratio. Calculate how much Caroline will earn in the 5th year at work. So we need our formula. UN is equal to 48,000 times 1.05 to the n minus 1. That's our formula. We want to find the 5th year that she's at work. So we need 48,000 times 1.05 to the 4. Try that on our calculator. 48,000 times 1.05 to the power of 4. Ooh, look, my calculator is giving me in standard form. So that's 5.83 times 10 to the 4. If I want this as a decimal, or no, sorry, not as a decimal, I want to see the expanded form of this. I can press document, settings, document settings. I'm in float 3, so if I just change to float, it should work for this one. There we go. Which is 58300. This isn't 3 significant figures and would be an accepted answer. Typically, because it's currency, we give 2 decimal places. So 58344.30, because who doesn't want those 30 cents? Okay, let's have a look at question 3. If you want, pause the video now. Have a go at question 3. Okay, the third term in a positive geometric sequence is 63. The 5th term is 57. Find the common ratio in the first term. Okay, so what we need to do for this one, this is an important sort of problem-solving tool that we're going to look at here. The third term, U3 equals 63. The 5th term, U5 equals 567. So ask yourself, to get from U3 to U5, how many lots of the common ratio do you have to multiply by? So U5 is equal to U3 times R times R. So multiplying by R will take you to U4. Multiplying by R again will take you to U5. So U5 is equal to U3 times R squared. Timesing by R squared will move you forward in the sequence 2 spaces. We can n solve this. Should we do for an n solve here? 567 is equal to 63 times R squared. Let's try an n solve for that one. You can just rearrange it. Divide by 63, take the square root. You guys like an n solve? Oops, we got a 6 there. So we want 567 is equal to 63 times R to the power of 2. Solve for R. Now, in the question, it says it's a positive geometric sequence. What this means is there's 2 possibilities here. We can get a positive value for R and a negative value for R. We only want the positive value for R. So I'm going to press comma 0, meaning find a positive value. And there we go. R equals 3. So reread the question again, see whether I found it. Find the common ratio in the first term. Okay, so I've only got the common ratio so far. I want the first term. So let's do that logic again. The third term in the sequence would be given by the first term in the sequence times 2 lots of r. This will move us up 2 spaces from u1 to u2 and then to u3. Put the numbers in that I have. 63 is equal to u1 times 3 squared. So u1, I can rearrange it. u1 is equal to 63 divided by 9. So 63 divided by 9, 7. Can, of course, n solve it. Algebra n solve. 63 is equal to u times 3 squared. Solve for u. Okay. Mr. Farmer buys machinery for $25,000. The machinery depreciates at a rate of 8% per annum. Per annum means for every year. Find the value of machinery after 5 years. Now this one gets a little bit tricky because the first term in the sequence is after 1 year. So let me show you a little bit of a graph for this one. So if these are the years, and this is the value starts off here at 25,000. It's going to go down each year like this. So after 1 year, we'll get the second term in the sequence. After 2 years, we'll get the third term in the sequence. So third, fourth, fifth. So 5 years is U6 because 0 years is U1. So using a geometric sequence now to solve this one. We need the formula. So UN is equal to 25k multiplied by our common ratio. Now our common ratio is 8%. That's 1 minus 0.08 to the n minus 1. So UN is 25,000 multiplied by 0.92 to the n minus 1. Now n and years are not the same thing. So if t equals number of years, t equals the number of years, n equals, so at no years, that's n equal to 1. So n equals the number of years. So at no years, n equals 1. So this is plus 1. This is t plus 1. So here we've got the formula in terms of the terms in the sequence. So UN is equal to 25k times 0.92 to the, well, n minus 1 is equal to t plus 1 minus 1. So t. So this is going to be up to the t. This makes it a little bit trickier in this question because the first term in the sequence is when there are no years. The sixth term in the sequence is when there's 5 years. So we want U5. That's 25,000. Oops, lowercase. 25,000 times 0.92 to the 5. Menu, algebra, and solve. Oh, we don't need end solve for this one. 25,000 times 0.92 to the power of 5. So it's gone down to 16,477.04. I've got to round up 2 decimal places for currency. Okay. That's it for today. Have a go at the exercises 10A and 10B on pages 462 to 466. And I will see you guys in a week's time.